Another summary statistic that applies to categorical variables would be finding the sample proportion. And the sample proportion is just a simple ratio, it's a simple fraction where you take the number of successes, which is whatever you're counting. You have 2 responses, 3 responses, whatever the favorable response is, you'll count that for the numerator, and then the total number of responses would go in your denominator. And if it's a small data set, you probably could just count how many successes there were out of how many total. But if you did have a larger set of data, you would be able to get these proportions in JUMP. So, it's just a matter of counting how many successes there are, whatever it is that you're counting, and divide by the total number of responses. But once you get to about 20 observations, then I'm really not interested in counting that anymore. So let's see how we would do that in JUMP. Here I have opened the data for example 7, where we were looking at checkpoint data and whether or not people were wearing their seatbelts or not wearing their seatbelts. So here, S represented wearing their seatbelts and F represented not wearing. Now, when we call these success or failures, then it doesn't necessarily imply like a good or bad thing. Success just means whatever it is that we're counting. So in our data, if we wanted to get the sample proportion, also go to Analyze Distribution like we've been doing for everything else. It's just this distribution will be it'll be categorical, but we'll still get some information that is categorical in nature. So drag that over to the Y columns and click OK. And you'll notice that we do create this little histogram with success and failures. But what we need right here is the number of failures, the number of successes, and it already calculates that fraction. Here, success would be 20 out of 35, but that divides to be 0.8333. Failures would be 5 out of 30, which has a proportion of 0.16667. So you can find the proportions just from JUMP, and that's really useful if you have lots of observations. If it's a small data set, you can probably just count. But in this case, it was much easier to use JUMP. Just a few notes about these population proportion of successes. We are going to use P here for the population. We will use P hat when we're talking about a sample proportion. And so we do have that distinction between samples and populations. It would be hard to know the population proportion of something. So P is often unknown, whereas P hat is just coming from our smaller sample. That's much easier to get. So the notation here, and we'll go back to see here, P hat, that is your sample proportion, whereas P is your population proportion. And like I mentioned, a success is not necessarily a good thing. It's just the characteristic that you're interested in. So whatever it is that you are trying to find out information about, that is what you'll count as a success. Now, the sample proportion is kind of like thinking about the mean, where every success is a 1 and every failure is a 0, and so that can help you get a sense of whether something is occurring about half of the time, 2/3 of the time, 90% of the time, and these sample proportions give you that measure between 0 and 1, and so you can think of this like a mean. And so there are 2 data sets in Canvas that I put here. Categorical data for 3.27 and numerical data for 3.25. If you wanted to go into JUMP before you did your homework and just practice getting proportions, practice getting those summary statistics, these would be 2 data sets that could be good for some practice.